Welcome to Newbie Introduction to Espresso. We had started this series, it's been, well, almost 6 months ago. And we've covered a lot of different subjects. The last one we did was buying advice. And I thought that there would be another topic that might be worth covering in more detail. Heat exchangers versus double boiler espresso machines. Now you're still in shopping mode, you haven't bought anything yet.
That's correct.
And so chances are, if you're looking at higher end espresso machines, you're going to run across these two types of espresso machines. So I want to dedicate a video to specifically covering the difference between these two and why you might choose one over another.
Great.
So we did talk about the types of different espresso machines. You've already used an example of a single boiler espresso machine. That was the Gaggia Newbie. And you remember that was the one where if you're using a single boiler espresso machine, you switch back and forth between brewing and steam temperature. You wait for it to rise to steam temperature, prepare your cappuccino, and continue, right?
Correct. Yep.
Then the next one that you had a chance to try out is a double boiler. This is the Iso Alex Duetto. It's a double boiler, so it has a dedicated boiler to brewing, another boiler dedicated to steaming, and thus you can go back and forth. You don't have to wait for it to change temperatures or whatnot. It's always ready for you. And then the one that we're going to be our focus on for this video is called a heat exchanger espresso machine. And on the exterior, they look very similar, right? They both have an E61 group head. They have a lot of chrome, they have a similar shape. But the fact of the matter is, the boiler design is quite different. And we're going to explain what those differences are. And to help me with that, I have some diagrams that are going to explain what this does. And once we've explained kind of how they work, we're going to go a bit over and explain why you might, the advantages and disadvantages of one versus the other. Perfect. And then finally, we're going to wrap up with a little taste test. We've dialed in these two machines with the same coffee, the same baskets, the same everything. The only difference was, and we'll see if you can taste the difference. Whether you have a preference or not, we'll just have to wait and see.
Awesome.
So in this diagram, what we have here is, and this is provided by Eric Svensson, a really talented engineer, and also with the help of Lino Verna, which shows the different parts of the exterior here, but shown schematically. So the group head that you see here, shown in this diagram, is machined piece of brass weighing literally about 9 pounds of brass. And then the rest of this part we're showing here, we collectively refer to as the group. So group head and group refers to it as a whole. And the idea of a group is to have as close to possible the desired brew temperature. So typical brew temperature for espresso is, say, 195 is on the really cool side, 198 medium, and 201, 202, 203, those are starting to get towards the hotter temperature. The idea of any espresso machine, its main goal is to have consistent temperature, shot after shot after shot, so it's predictable. The different designs may have different usage patterns. You see, remember, I think in the previous video we talked about flushing, and you asked, what exactly does that mean? Flushing the group is a way of equalizing the thermal characteristics between these different parts of it. So the group overall, when you flush water through it, stabilizes, equalizes. The idea being is that when you go to make your espresso, the temperature will be the same, consistent, predictable temperature each time. Okay. So briefly on the double boiler, there it's really simple and straightforward, because essentially the brew temperature out of the brew boiler is delivered to the group head, and hopefully that's about what the temperature comes out to be, right? But another design, which is the focus of this video, is called heat exchangers. And heat exchangers, they actually only have one boiler, the steam boiler. And so you say, so where's the brew water coming from? And that's kind of the neat trick. What they do is they rely on the thermal stability of the group head to essentially temper the water to the correct temperature. You see, so the steam boiler, which is about 250 degrees, it's pretty darn hot, way over brew temperature, right? But if you pass this, if you see it has a tube here, if you pass a copper tube through it, you can run fresh water through this, you see, and they will be flash heated to approximately brew temperature.
Interesting.
Okay, yeah. You see, what's neat about that is that it enters at, basically room temperature, gets flash heated to approximately brew temperature, and then the group head acts as kind of like a shock absorber. If it's a little bit too high, it brings it up. If it brings it a little bit too low, it warms it up. Thus, the idea is that this group head is at the desired brew temperature. But it does require that the barista be aware of some of this difference. Because you can imagine, this is all filled with water, this heat exchanger. When that water sits idle for a while, what's going to happen?
All the heat's going to stay in there, right?
Indeed. In fact, it's not going to be just 202 or 201. It's going to approach essentially the steam boiler temperature, right?
Yep.
And so that brings us to what is commonly referred to as the HX flush.
Okay.
Right. You see, what you're doing is that you are pushing the superheated water that's over the boiling point of water, out of the heat exchanger into the group. Now you see, the design has this already in mind. So like the group head typically will idle slightly below brew temperature. Thus, when you flush it, it heats up the group then to pretty much spot on where you want it.
Okay.
And then when you go and then draw the extraction, the water flowing through the heat exchanger arriving here is very, very close to brew temperature. Now, when I say very, very close, let's kind of get a feel. How close is close, right? Yeah. Typically, brew temperatures for typical prosumer espresso machines, they might vary as much as 4 degrees off the mark.
Okay.
You see, 4 degrees is considered acceptable, and depending on how picky the person might be, right? As you move up the price point and the design, like for example, a double boiler would probably be able to cut that by about a quarter. So being within a degree, or degree and a half, that's pretty reasonable. As you get into the absolute world-class, best double boilers on the planet, they'll be able to track to about half a degree, maybe even a teeny bit less, but they're really, really precision, being able to dial in a specific temperature. And that kind of brings up some of the question that a lot of people ask is that how important is brew temperature? Because there's some people who feel that having the absolute precise brew temperature, a flat temperature, one that rises to the brew temperature and remains flat, is kind of the nirvana.
Okay.
And others, they feel that, maybe there's an advantage of having a brew profile that isn't just up and straight across, but one that might have a hump in it at the beginning.
And then sort of decline.
And then decline afterwards, exactly.
And that's the temperature during the brewing process you're talking about.
Correct.
Okay.
Right. So, because of that initial, heating cycle we were talking about, most heat exchanger espresso machines, and they vary slightly by design, what they'll do is the initial brew temperature during the brew cycle will initially spike. Okay, it'll spike up to say, 202, 203, maybe a little bit higher, and then it'll slowly decline over the course of the extraction.
Okay.
Now, we can have a big long debate about which is better, a flat profile, a humped profile. Remember, I think we talked about this in another video. Why is it we want to manipulate brew temperature? Do you remember we talked about this? Okay, tough question, okay? Well, you see, the thing is that years ago, when I first started into this hobby, when I started into this hobby, that was considered, the end-all, be-all was temperature control.
Yeah.
Right? Everyone, that's all what they focused on, control it as tightly as possible. Well, that was influenced by some very, vocal people in the coffee community. Nowadays, people are a little bit more flexible on that point. It isn't so much, how can I control the temperature to a half a degree? The main focus is, how can I reproduce the same temperature time after time after time? Thus, I'm an advocate of consistency. Whether the temperature profile is flat, whether it's humped, we can have that discussion if you like. My main concern is it reproducible? If it produces the same temperature profile each time, then we can discuss how that affects taste.
Yeah.
And so taste, when we talked about in the last video, I argue that brew temperature is used to control acidity or brightness.
Okay.
Right? So now are you starting to remember? We said when brew temperature goes up, what happens to acidity?
Down.
Correct. And as the temperature goes down, you have sourness or fruitiness that increases, right?
Yep.
Well, you might ask, well, what happens if you have something that starts high and ends low? You can see it brings up an interesting discussion.
Yeah.
And so what the heat exchanger allows you to do is to produce, with a little bit of help from a barista, a temperature profile that has a slight hump with decline to it typically.
Okay.
And, whether one is better than the flat or not, that's a whole...
So a double boiler is typically going to incline and stay flat?
Pretty much.
Or a heat exchange is typically going to go up and go down a little bit?
Heat exchangers typically spike a little bit and then decline. Some decline quickly, some decline more slowly.
But generally speaking, would that be a fair...
Yeah, that's a fair assessment. Most double boilers will either stay flat or they might incline ever so slightly. But the idea is to produce a flat one. That's pretty much what it is. So that kind of covers the the whys and what fors of how heat exchangers, why they are the way they are. So this has an impact, of course, on, remember this flush we were talking about impacts how the barista uses that. We talked about the HX flush. I'll do this just for a quick demonstration to show you. The HX flush varies a little bit from machine to machine, depending on how the manufacturer tuned it. This particular machine is the ECM Technica Pro. Okay. The Technica Pro has been tuned for home use, and thus it has a relatively short HX flush. Now if you pay attention real closely, you'll hear the sound. Okay. Done. Okay, that's it.
From the steam.
That was the steam. That noise that you heard was the superheated water exiting the heat exchanger, flash boiling at atmospheric pressure, and then dying off, right?
Yep.
So with if you tune, some heat exchangers require short flushes, some require long flushes. In the forums, I provide kind of a lexicograph for these different type of heat exchangers. I'll introduce them briefly to you for your edification, but I basically classify them as 3 different types. The ones I call dragons. Dragons with heat exchangers, what they do is they flash very vigorously, like that. They die off, and then they're ready to go. So you flush, they make a bunch of noise, and then you go. You see, one thing about dragons, they have a very aggressive flush, and then they're ready. They have very short thermal memory. They return to that initial state in short order.
So you got to move quickly.
Not so much you have to move quickly, but like, say for example, you're doing back-to-back shots. With the dragon, you make your shot, you flush, you make your shot. A minute goes by, you're going to have to flush, and it's going to behave the same way. Okay? The next type, and this point will become obvious in just a second, the next type I call mixers. Those are ones that mix the heat exchanger water with fresh water at the same time, coming in at room temperature. So they mix them at the same time. And you notice we flushed this maybe a minute ago or so, right? You see how much shorter it was?
Yeah. Yep.
And so that's the difference is that a mixer will have, a dragon would have done the exact same thing the second time around. A mixer, what it does is it kind of settles in to where it wants to go, you see? And so you have like a longer flush the first time, and then the flush becomes shorter, and it essentially returns to zero. If you keep using it back to back to back, the flush just goes away. With a dragon, the flush,
it's right there.
It's always the same every time. Then the last type, which is really the provenance of commercial heat exchangers, I call agnostic. In other words, they just don't care really what you do. You flush one time, they'll do that little fizzle thing if they've been idle for a long time, and then at that point, there's really no flush involved. It's like enough to clean the screen, and that's all. You see, because they've got a really super massive group head, and it's been tuned a certain way that it's made for back-to-back uses, and thus those are the 3 types.
So large commercial espresso machines, you can have double boilers or you can have heat exchangers.
Right. In fact, now, for most Americans, they've probably seen Starbucks, which used to have La Marzocco double boilers as their standard equipment, right? In Italy, heat exchanger espresso machines are the norm, and double boilers are kind of the outliers. Where in the U.S., especially the last 5 or 6 years, there's been kind of a flip in that. Now double boilers are getting a lot of attention because, and primarily, so why is that? Why is the the double boilers becoming so much more popular in some regards? Part of the reason is that the operation is really simpler. It doesn't require the barista to really understand any of this this operational detail. Now again, in my opinion, this is kind of like the automatic transmission versus manual transmission discussion all over again. Is that if you don't mind an extra manual step, they both can produce very good results.
Sure.
A good driver does not blame the car, right? Just like a good barista does not blame the equipment. A good barista that. But people are attracted to double boilers because of their simplicity.
Sure.
You can pretty much flush one time and to knock off your coffee grounds and you're on your merry way, right? With this, you have to be aware as like, well, was this used within the last 10 minutes? If the answer is no, well, then the flush is going to be longer the first time. It's not hard to recognize.
No, not at all.
Like in this particular machine, it's kind of like, you could use that water to heat up your demi-tasse. Put in a demi-tasse, flush into the demi-tasse, the cup gets warmed. By the time you prep it, it's ready. It's really that simple. But some people, they're intimidated by that, and hence this is why I want to do this video, is get a chance to see the two side by side. Okay. So we've talked about heat exchangers, double boilers, how to use them.
Real quick, demi-tasse, small cup?
Yeah, right. Yeah, that's an espresso. That's just an espresso cup. I think it was also one thing before we get on to the actual taste test. We want to do a taste test to compare these. Maybe just talk a little bit about advantages and disadvantages. Is that, how is it that I test these machines? And that's what I set up the Duetto with this monstrosity on the end here. It's this very large portafilter. This is called a Scase thermofilter.
Okay.
What it is the SCAA and a gentleman known as Greg Scase developed a standard for measuring brew temperature exiting from the group head. So that way you can calibrate different machines at different locations. It was done for competition primarily. Gotcha. The WBC, the World Barista Competition, they needed a standard to say, when we do a competition in the West Coast, is it the same as the East Coast as it is overseas? And thus they developed a way of measuring it so that way all the machines were calibrated to the same standard. Well, I use this as a way of mapping out what is the optimal routine. Because questions a consumer might ask is, how long does it take for this to heat up? Well, here's a standard way of measuring that question. When it has reached a steady temperature here, I know that it has warmed up to ready to go temperature. They might say, well, how often, you say I have to flush, how much? Well, if I have this, I can answer that question, in a way that, someone who buys it will be able to reproduce that, right? If I give them instructions, it helps an evaluator give precise instructions on how to use it. For a double boiler, what you're trying to do is you're trying to figure out, how accurately does the display temperature match to the real temperature at the group head, right? I mean, the display temperature, I often want to warn people, is just because it's digital doesn't mean it's right. So if it says, this one says, 201 on the dial, it doesn't necessarily mean that's 201 coming out the group head. We have to verify that's in fact true. In a well-designed one, it is true, right? But the fact of the matter is that a digital display sometimes gives people a false assurance. So keep in mind that just because you measure doesn't make it right. Now, remember those 3 characteristics of heat exchanger ones I talked about? It's really easy to map out how it behaves using a thermofilter. Because what I can do is flush it, wait 3 minutes, flush it again. If it sounds the same, then I say, it's probably a dragon, right? If I hook up this, then I can help determine, well, is this guy a mixer? Does his profile decline over time? Because mixers typically decline over time. Where an agnostic tends to be flat or maybe a little bit rising, you see? And so that way I can kind of give people a hint, because just like when you're driving a stick shift, you can choose when to shift, right? Well, this is something that's kind of interesting about heat exchangers, is that you can tune the temperature on the fly, you see? So say, for example, if you flush it and then wait a period, which I call the rebound time, you can extend that rebound time to increase the size of the hump and therefore make the temperature rise more quickly.
Okay.
You see, so if you flush, wait 10 seconds, then pull the extraction,
Yeah.
you'll get a slower, lighter hump. But if you wait, say, another extra 10 or 15 seconds, you're going to get a much more dramatic hump.
Yeah.
You see, and so say, for example,
Because you have more of that heat that's built up.
correct.
Yeah.
You see, so in some regards, heat exchanger machines are really, really favored by those who like that hands-on way of manipulating the temperature.
Yeah.
Other people might say, I don't want that sort of, that's inconsistency.
Creates another variable for me to mess up.
Right.
Yeah.
Well, so that's why for some people, these are more of a, require a bit more skill.
Yeah.
Now, again, if given a review and feedback from people in the forum, it isn't that hard to learn how to just use it.
And you can, for me, I'm not intimidated by that because you can just hear it.
Yeah,
It's
right.
a very easy, cue.
Well, also to give a plug to Eric, the gentleman who put together this diagram, he sells a nice little thermometer that fits in this little slot right here.
Okay.
You see, so if you want to have digital clarity,
Yeah.
fine, no problem. What you do is he mounts a thermometer that goes directly into the brew path. So if we were saying like here, it literally mounts, see that little channel right there?
Yep.
It mounts right there. And thus the water that's going to the brew head, it's measuring it as it goes by.
Instantaneous, yeah.
Right, so if you really want to be able to dial in with precision, similar sort of profile every time, but you don't want to have to think, this gives you a way of doing that.
Yeah.
So that was
pretty sweet.
Yeah, I mean, so it's and now before we go on to the tasting thing, I want to talk just a little bit about advantages and disadvantages. We've already kind of touched on them a little bit. Obvious advantage of the double boilers is a little bit more simplistic barista routine, right? The flushing routine is flush to knock off the coffee, on your merry way.
Correct.
This one requires a little bit more thought on that. You can add in Eric's thermometer adapter, and then that kind of puts them on equal footing as far as the consistency question comes into play. One thing I'm sure that you're going to be thinking about real soon is what about cost?
Yeah.
Well, you see, this has two boilers. That means it has two heating elements. That means it has additional controls. That comes with a cost, right? So heat exchanger espresso machines as a class are going to be less expensive. That's just, and it varies depending on the manufacturer. It could be, $300 to $600 difference.
Wow.
So for, let's say, a typical heat exchanger might start in the $1,200 to $1,400 range. It's hard to get into the double boiler range of this class. Like this one is around 26 or something, I think.
Okay.
I'd have to look to be sure, but it's well over $2,000.
Okay.
This one is below that, probably about $300 to $400 or so. I'd have to check the prices to be sure, so look that up. But as a class, heat exchangers are less expensive.
Gotcha.
With less parts means less chance of things breaking. Right? So, heat exchangers, they have an advantage because they have less parts. Now, whether that's going to matter over the long term, we can argue that if you like. But, generally speaking, the simpler the espresso machine, the less likely it is to break.
Quality, as far as craftsmanship, do you see them on the same level?
Yeah, for the most part.
You can get a heat exchanger at the same or better quality than you can, like for your highest end. As far as build quality, are you going to see about the same, or does one sort of exceed the other?
Well, there are heat exchangers are really popular in Italy, and thus there's a very long history. So you're going to see
some really high end.
Indeed.
Okay, gotcha.
Cimbali, for example, makes the Cimbali Junior is a model that's common in Italy, but at a commercial next class up, and it's a tank. You could use it to change your car tire. You could put up. It's that sturdy. But you do raise an interesting question: is that if you want to hit a certain price point, if the manufacturer wants to hit a certain price point, someone who makes a heat exchanger is going to have a little more flexibility, right? Because they're going to be able to use better components, potentially things like you look at this one and it has this has toggle steam, and this one has a knob. This one's a bit more blingy. It has nicer porta filters and whatnot. So you can find similar sort of bling in a double boiler.
Sure.
But these two this is still going to be less expensive.
Right.
You see?
Right.
So even though this one has, some nice bling features that the Duetto does not, it's still going to be less expensive. So that's where you're seeing the trade-off, is that someone who's manufacturing a heat exchanger may choose to, make themselves more competitive by using a higher quality component at the same class, so they compare more favorably with double boilers.
Gotcha.
You see, so
Gotcha.
so advantages, disadvantages. We talked a bit about cost. That's a big one. Advantage double boiler, simplicity. No argument there. Perhaps on longevity, less parts. That's kind of a nice thing.
What, the heat exchanger?
Yes.
Yeah.
Well, I mean, in fact, if you get something like a lever espresso machine, which has, it's really just a tea kettle on steroids with a piston on it, right? I mean, those things are going to last really for a long, long time. There just isn't much to break. And if they do break, they're very easy to repair. The more complicated the technology, the more likely you are going to take on the repair yourself.
Sure.
Right? So, I mean, that's just a fact of the matter of a simpler design. Let's see, is there anything else? Those are the ones I think are kind of the main ones I want. Do you have any questions before we go into the tasting?
No, I think that's pretty good.
So what we're going to do now is we're going to prepare 2 espressos side by side. And these have been dialed into the same coffee, same grind, same amount of coffee, about 17 grams. We'll taste them side by side and see if you can pick up on some differences.
Awesome.
Now, I'm not going to say one or better. We're looking for differences.
Cool.
Okay, let me get a second to set that up, and we'll be right back.
Great.
So we're back, and now we're going to do a taste comparison between the ECM Technica and the Alex Duetto.
Okay.
Double boiler versus heat exchanger. You may taste a difference. We'll see.
All right.
Let's go. So we're going to let this pour for 25, 27 seconds thereabouts. I intentionally didn't use bottomless portafilters because sometimes that gives gives people confidence about that might not be true. So this way it's a little more of a blind tasting.
Okay.
So we'll go ahead and cut yours and cut this, and there we go. So. Well, just to make it interesting, I'll give it to you one at a time. How's that?
All right.
Okay.
Close my eyes.
Just look away for a moment.
Right.
Okay, there you go. So we're not going to be too crazy about it.
Okay.
Okay, that's number one.
I can taste the difference.
Okay. So how does it seem different to you?
I don't know. I mean, I guess this one seems a little bit more fruity.
That's correct. Yeah, sure. Exactly.
I don't know which one it would be, but I can definitely taste the difference.
Right. And that's, and as a matter of fact, that's from the Technica.
Okay.
And remember we talked about that temperature profile?
Yeah.
Well, I mean, we can only guess. I'm not going to claim to be, the end-all, be-all expert on this.
Yeah.
But a declining profile can have that effect, where it produces a brighter, more fruity extraction.
Okay.
My guess is because in part you're getting a higher temperature and a lower temperature. That's my theory. But I mean, both of these were very good.
Very good.
They were very good.
Yeah.
The Duetto Espresso to me was very consistent. It was correct to this profile. This one had the temperature of the acidity level was turned up a little bit, and that's what I hope you would notice.
Absolutely.
Right?
Yep.
Yeah. So that's a difference where if we had flushed it differently, I could perhaps push that backwards and forwards, right?
Okay.
You see?
Yeah.
So there's all sorts of techniques we talk about.
Keeping a little bit more heat in there.
Correct.
Yeah.
Like say for example, if I let it rebound longer, that would produce a higher hump. Versus I flush too long and then let it recover for a long time. You know, these are different ways. It's all covered in the forum. You know, we can talk about this way, but the basic gist of it is that with heat exchangers, you have a little more control, but it's control that you have to kind of trust yourself to use.
Sure.
You can use Eric's thermometer thing to give you some digital confidence. But in some sense, what's kind of interesting about these is that you drive a bit more by the seat of your pants as opposed to relying on gauges and whatnot.
Sure.
Which works for you? We're going to find out. Philip is going to take the Technica for a test drive later next month, and we'll see what he thinks about it, and we'll look forward to your comments in the forums. Anything else?
I think that's it.
Great. See you next time.